All right, let's get right into it. Today we're doing a deep dive into securing what is arguably the most critical piece of your entire infrastructure, your certificate authority. We're going to lock it down with a YubiKey, and I'll walk you through the precise technical details you'll need to do it right.
So, first things first, let's be crystal clear about what we're protecting here. A certificate authority, or CA, is the absolute bedrock of your public key infrastructure. It's the entity that signs and issues certificates, basically vouching for who's who in your digital world. If that CA's private key gets compromised, well, your entire trust model just shatters. The stakes don't get much higher than this.
Here's our game plan. We'll start with why hardware is completely non-negotiable for this kind of work. Then we'll peek inside the YubiKey and look at the specific PIV tools that make all this possible. After that, we get practical. We're talking full implementation guides for both Windows and Linux. Then we'll discuss the real-world gotchas and limitations. And finally, we'll wrap up with a direct comparison to help you figure out which route makes the most sense for you.
Okay, Section 1. Let's start with the most fundamental principle. Why are we even bothering with a physical device like this? Well, it all boils down to one simple idea: creating a truly unbreakable vault for your most valuable secret.
This right here, this is the golden rule. It governs everything else we're going to talk about. The private key of your CA must never, ever exist on a disk or in memory in a way that it can be copied or extracted. The second it's exposed, you have to assume it's stolen and your CA is burned. There are no exceptions to this.
And this is exactly where a device like a YubiKey shines. It's built to enforce that golden rule. How? First, the private keys live inside a dedicated, tamper-resistant chip called a secure element. Second, and this is the absolute key, all the heavy lifting, all the cryptographic operations like signing a new certificate happens inside the YubiKey. The key itself is never even loaded into your computer's memory. It's non-exportable by its very nature, and you gate access with the PIN and even require a physical touch.
Now, to make this work, we're not using the YubiKey's typical one-time password features. Nope. We're tapping into a much more powerful, standardized application that lives on the key. It's called PIV, which stands for Personal Identity Verification.
So let's look inside this PIV applet. It's all based on a NIST standard, so it's predictable. You get these things called slots, which are like secure pockets for keys. Some are for specific purposes, like slot 9A for authentication. But what's really cool for us are the 20 generic slots, from hex 82 to 95, which are just perfect for storing our custom CA keys. On a YubiKey 5, you get a total of about 24 of these slots. And it talks to your computer using a standard interface called PCKS11, which means it plays nice with all sorts of tools like OpenSSL. Now, before you even think about setting this up, you've got a massive strategic decision to make. Do you generate the key pair on the device, or do you import a key that already exists? Generating it on-device is the gold standard. It offers maximum security because the private key is literally born inside the secure element and never, ever exists anywhere else. Importing is less secure because, well, that key had to exist somewhere else before you imported it. It's really only for cases where you're migrating an existing CA. For anything new, on-device generation is the only way to fly.
All right, time to get our hands dirty. Let's walk through our first scenario, implementing this in a Windows environment, which, as you know, is often deeply tied into Active Directory.
The magic on Windows is the YubiKey Smart Card mini driver. This little piece of software makes the YubiKey present itself to the operating system as a standard smart card, and that is incredibly powerful. It means all the tools you're already familiar with, like the Graphical Certificate Manager in the MMC or the Certotil command line tool, just work right out of the box. This native integration is what enables those big enterprise features like Smart Card Logon and Certificate Auto-Enrollment from Active Directory.
And here's a quick practical example. If you want to check that Windows sees your YubiKey and all its certificates correctly, just pop open a command prompt and run certutil-sc info. This command pings the smart card system and gives you a full readout of everything on the device. Honestly, it's the first command you should run if you're ever troubleshooting anything. Okay, let's switch gears and jump over to the Linux side of the house. As you'd expect, it's a different world, one that's much more focused on the command line.
On Linux, pretty much everything revolves around that PKCS11 interface we talked about. You use a shared library like libukcs11.so to act as a bridge between your applications and the YubiKey. And all your management is going to happen on the command line, using fantastic tools like Yman and Yubico Piv tool. This approach is absolutely perfect for headless servers or for scripting and automating your CA management, since it plugs directly into things like OpenSSL and OpenSSH.
So let's look at a real command.
Say you want to generate a new key pair right on the device in slot 9A. You'd run ycam-man piv generate key 9A pubkey.pem. Let's break that down. ycam-man is the tool, piv says we're using the piv applet, generate key is what we're doing, 9A is the slot, and pubkey.pem is the file where we want to save the public key. The private key, as always, it never leaves the hardware. It's that clean and simple.
So we've covered the how. Now let's talk about the operational reality. Because as great as this setup is, it's not a silver bullet. You have to be keenly aware of some important constraints and limitations before you go all in. The first and most obvious one is just raw capacity. You've got about 24 slots to work with. That's it. That's fantastic for a super secure offline root CA, maybe a couple of intermediate CAs. But this is absolutely not designed to replace a full-blown hardware security module, or HSM, where you might need to manage hundreds of keys.
And beyond just capacity, you've got other things to think about. Performance-wise, it's not built for signing thousands of certificates a minute like an HSM. On the plus side, you get a feature called attestation, which is a way to cryptographically prove that a key was generated on the device. That's huge. And of course, there are FIPS-certified models for compliance needs. But all this comes back to that no export rule. The very feature that gives you all this security is also your biggest operational headache.
And that leads us to the single most important question you have to answer before you start this journey. Since you cannot export the private key for a backup, what is your plan if that YubiKey is lost, stolen, or just fails? You must have a solid plan for redundancy and recovery, whether that's multiple keys, a well-documented recovery ceremony, whatever, before you generate that first key.
Okay, let's wrap this up by putting it all together. We'll do a quick head-to-head comparison to help you decide which platform is the right fit for your YubiKey secured CA.
Looking at this table, you can see that for the core crypto functions, both platforms are incredibly capable. You can generate keys on device, you can import them, and you can use standard interfaces like PKCS11 on both. For most things, they're neck and neck. But the real decider is that very last row, Active Directory integration. If your CA has to live and breathe in a Windows enterprise and support things like automatic certificate enrollment for users and computers, the seamless integration from the native mini driver on Windows is a massive advantage.
We've laid out the roadmap. We've shown you a clear, hardware-enforced method for protecting the very core of your digital trust. The technology is here, and it's more accessible than ever. So the final question really isn't about the tools anymore, it's about you. Now that you know how, will you take the steps to make sure your root of trust is truly secure?